Hi, ladies and gentlemen, welcome to our first notes of Unit 3. So this unit is going to be talking about polynomials. We're going to start today off by just going over general rules of polynomials um, and definitions. So when I say these terms in class, you kind of know what I'm talking about. So this video is going to require a lot of listening to me talk, pausing the video, because there are going to be a lot of writing down. If you look down at the note sheet that I'm giving you, you'll notice that there's 3 columns. In the first column is where you can write down those definitions. Okay, in the second column, I'm going to be giving you an example of what the definition is. So you can kind of see a concrete example of what I'm talking about. The third column is for you yourself to write an example. And I do ask that you pause the video and do all 3 of those things. Take as much time as you need. Again, I'm going to talk a lot faster than you write, so make sure you take the time to actually write this stuff down. So the first one, a term is a number, variable, or the product of number and or variables. Okay, so we've talked about terms a lot. You've seen terms before. Here's some examples of terms. Okay, 4x squared, that's a term. 3, that's a term. 2x, that's a term. All of those are examples of terms. So pause the video, write your own example. All right, let's take a look at a coefficient. Okay, so you've heard me use this before, especially when we were talking about solving systems by elimination. I always said coefficient, coefficient, and maybe you didn't know what that word was. A coefficient is the numeric factor of a term that has a variable. This part really, right here, is really key, that has a variable. So if something is just a number, it is not a coefficient. So if I had the term 3x, then 3 would be the coefficient. Okay, if I had the term 4x squared, then 4 would be the coefficient. Okay, let's take a look at the degree of the term. Again, make sure you're writing your own examples as well. The degree of the term is the exponent on the variable of the term. Well, exponent. Hopefully you remember what an exponent is. So let's say we had the term 3x squared. That little number, that 2, that's the exponent. When we take something and we raise it to a power, we call that power an exponent. So because this one has a 2, okay, we would say that this term is second degree. Okay, so again, go ahead and pause the video, write down your own example, make sure you have the entire definition written down. All right, let's take a look at a constant. A constant is a thing that is only a number. Okay, a constant is a thing that is only a number. So sometimes when we write out polynomials, we have 4 at the end, or we have 6 at the end. Whatever it may be, we don't want to have any letters in our constants. Our constants are just a number. Then we want to talk about like terms. So this one's a little bit lengthy. Okay, like terms have the same exact variable raised to the same exact exponents. Okay, all constant terms are also like terms. So let's write an example of some like terms. So 3x squared and 2x squared. Both of those are like terms. Okay, they both have this exponent of 2. That exponent of 2 makes them like terms. Okay, so why don't you go ahead and write down an example of your like terms. Make sure they have the same exponent. The coefficient can be different, but the degree of each term needs to be the same. All right, let's talk about what a polynomial is. That's what this entire unit is on. So we now have the vocabulary that we can actually talk about polynomials. And all polynomials are a bunch of terms that are separated by pluses and minuses. So we talked about what a term is. We talked about how we can identify parts of that term. Now, a polynomial is a term separated by pluses and minuses. So 3x squared plus 6x minus 4. That's a polynomial. We have 3 different terms, and they're separated by pluses and minuses. Okay? All right. Let's take a look at the next one. Again, make sure you're writing your own examples. Next, we're going to talk about the degree of a polynomial. Now, if you remember, the degree of a term is the exponent. Is the exponent of the term. That's the degree of the term. But now we want to talk about the degree of the entire polynomial. Okay, so the degree of the entire polynomial is the largest exponent of all the terms in the polynomial. Okay, so the degree of the polynomial is the largest exponent of all the terms in the polynomial. So let's say it's something written like this. I had 3x to the fourth plus 6x cubed minus 3. Okay, so now I want to look for the highest exponent. And the highest exponent is 4. So we would say that this is a fourth degree polynomial. And I say fourth degree because the highest exponent in that polynomial is fourth degree. So what I want you guys to do right now in your own examples is to write a polynomial and then indicate what the highest degree is. So you don't have to necessarily write down all of this, okay, because it's a lot of information. Here's what I'm going to tell you what's important. Okay, we're talking about the standard form of the polynomial. This is the biggest thing right here that you write down. The polynomial is in simplest form, and the term is written in descending order. Well, when we're talking about simplest formed, that means all like terms are combined. And it also says that down below. The second part of this is more of an FYI for you. If you'd like to find room and write it down, you're more than welcome to pause the video and do so. So that all this means is that the term with the highest exponent is written first, and then the next highest, and then the next highest, and so forth, and your constant is always written at the end. Okay, so you're just making your exponents go down. Remember, the exponent is a little number, typically on the x, okay, and then you're just going to write it going down with your constant at the end. All right, let's take a look at the leading coefficient. The leading coefficient is the coefficient of the first term, but this is only true if the polynomial is in standard form. That is a big deal, so make sure you put that on your sheet. Make sure you highlight that to yourself somewhere. So let's say we have the polynomial 4x squared plus 3x minus 2. Okay, that's in standard form. I know it's in standard form because my exponents are going in descending order. Remember, if there's an x that doesn't have an exponent, then the exponent is 1. Similar to like if there's no coefficient, the coefficient is 1. So we have x to the first power. But here is my term with the largest exponent. And because it's in standard form, it's the first term. So if I were to ask for the leading coefficient, I would say that the leading coefficient is 4. Okay, the leading coefficient is 4. Remember, you can only take the first term when it is in standard form. Okay, I just want to kind of take a look at this. So you can just put your pencil down, relax, and kind of listen to this because this is relatively important for what we're going to be doing next. So what I'm going to do is I'm going to let cubes represent x cubed. So here I have 5x cubes. I'm going to let squares represent x squared. So I'm going to use red to represent negative. So here I have negative, and I'm going to use lines to represent x. So here I have a positive 2x. So I'm just going to go fill in all of these with cubes and squares and then lines. So we have 6 lines here. Now, here's how this works. Blue cubes are canceled out by red cubes. Think about it. Could you cancel out a cube with a square? No. So what I'm trying to show you is that cubes only go with cubes. Squares only go with squares. Lines only go with lines. So I'm going to cancel out each cube, each blue cube with a red cube, and then I'm going to see what's left over. I'm going to cancel out each red square with a blue square, and each blue line with a red line. Now notice I didn't do anything with the constant. That's because there's only one constant in here. So now I'm going to look at what I have left. I count. I have 1, 2. I have 2 cubes left. So I have 2x cubed, and that makes sense. If you take, oops, I should have 3. Whoops. Apparently I didn't count well. Okay, if you take 5x cubed minus 2x cubed, I think I took away 3 instead of 2, then I'd have 3 cubes left. Okay, next, I only have 1 squared left, which makes sense. If I were to take negative 2x squared plus an x squared, negative 2 plus 1 is negative 1 x squared. And lastly, here I have 2x minus 6x, so notice I have 4 lines left. 2x minus 6x is negative 4x. So that was just a visual representation of what we're going to be doing for the rest of this lesson. So flip your page over to the back side. So we're going to start by writing this polynomial in standard form. To write it in standard form, I need to combine all like terms and get my polynomial going with exponents in descending order. So I'm going to start and I'm going to look across the whole thing and I'm going to figure out which one of those has the highest exponent. Well, the highest exponent I see is 4 to the third. X to the third. So I have 4x to the third here, and I have 3x to the third here. Okay, so I have two terms, and now I'm going to combine them. The biggest thing, when I'm combining them, I do not add the exponents. I do not add the exponents. Please do not add the exponents. We're going to add the coefficients and leave the exponents alone. So I'm going to take 4 plus 3, and that gives me 7. And I'm going to keep it as x cubed. I am not adding those exponents. Now, for me, it's easiest when I'm putting things into standard form to cross them off as I go. Next highest exponent I see is 8x squared minus 5x squared. I'm going to subtract the coefficients, keep the exponents the same. 8 minus 5 is going to give me plus 3. I'm keeping it as x squared. Think back to the last slide. When I canceled things out with the blue and the red, I didn't change the fact that they were a square. I just canceled them out. Same thing here. We're not changing what it is. We're just adding up how many we have. Next, I have negative 3x plus 5x. Let's do that in blue. So I have negative 3x plus 5x. So negative 3 plus 5 is going to give me positive 2x. And last but not least, I have 8 minus 12, which is going to give me a negative 4. So there's my polynomial in standard form. The next question wants to know how many terms there are. Well, all I have to do is count how many things are separated by pluses and minuses. 1, 2, 3, 4. How many terms are there? 4. Then I want to check, what is the degree of the fourth term? So I'm going to count to the fourth term. 1, 2, 3, 4. Well, the fourth term is a constant. So here's something interesting to learn about the constant. The constant actually has a degree of 0. Okay, the constant has a degree of 0. And we're going to go ahead and cross this question out because there is no sixth term. So that really is just a silly question. Okay, now we want to list all the coefficients. Think back to a couple slides ago when I talked about coefficients. Coefficients are only the things that have x's. So 7 is going to be a coefficient, 3 is going to be a coefficient, and 2 is going to be a coefficient. Okay, 4 is not a coefficient because it is actually a constant, which answers number 5 for us. And I'm taking the sign with. Okay, if it's a negative, I'm going to write it down as a negative 4 if we're subtracting. Let's take a look at this next one. So first we're going to write it in standard form. So I have 5x to the 5th, that's my highest exponent. My next highest exponent, I have x cubed. So again, I'm not adding exponents. I'm taking 3 minus 2, which is plus x cubed. And then I have negative 2x minus 4x, which gives me negative 6x. Last but not least, I have 4 plus 5, which gives me 9. The degree of the polynomial is the highest exponent, and the highest exponent is 5. So the degree of the polynomial is a 5th degree. The leading coefficient is the coefficient of the term with the highest degree, so the leading coefficient is 5. So I want you guys to go ahead and finish up this on your own. So really try and get those in standard form. Okay, remember you want your exponents going from highest to lowest. You want your constant at the end, and remember that a constant is not a coefficient. So please go through and answer these 5 questions. Once you're done, I want you to go ahead and answer these questions. So finish out the back of this worksheet. And then please remember to take the Schoology quiz once you're done so that I know you watched the video.